1.25 millimeters today. So for the slow extrude, I don't put any sort of pulling action on it. You will see later. You can measure the size. You'll see how much is it. Might be a bit more than 1.25. But for the faster one, that definitely smaller. But let's see how small can we get. We still retain the connectivity in the fiber. And he said,
how consistent can you get the?
Sorry.
How consistent can you get the width?
For what? How consistent?
Just a certain diameter.
Well, if you don't pull it, if you let it go, for example, if we extrude straight to the floor, it will be gradually getting smaller because when you're extruding more material, gravity takes charge. So what I'm trying to do is try to maintain the same amount of, but I think you need, roughly speaking, a meter of each sample, isn't it? So let's see. For the faster collection, definitely is much better.
Right.
Because you have this mechanical rolling action.
Yeah.
It's automated, so unless your materials have some degradations in it, otherwise you shouldn't have a uniform fiber. Well, if it's still fiber. At a lower temperature, the rollers, when it catches the fiber, it doesn't actually scorch it because it's cooled down properly. But with a higher temperature, it's a bit difficult for the cooling down action, and then, but it's good for the conductivity. This whole idea for the temperature change and mixing basically is called the dynamic percolation. So we want to dynamically control the percolated nanotube network. The network will be perfected a little bit if we extrude the material in a higher temperature range for this material. The reason being that nanotubes will have more time during the material's cool down to have an effect called reagglomeration, and then that creates a desired way of percolating the network of nanotubes.
What's the largest diameter size die you can use on this machine?
This one has a smallest die of 0.3.
Right.
So that's actually very difficult to make in terms of engineering.
It's chunky.
I think that's enough. Almost a meter. Yeah. So let it cool down a bit. Leave it here.
Okay, so first departure from the SOP is it's not the right machine.
Yeah. Wow.
So that has to be noted.
Okay.
To explain that a little bit, but have you, Wendy?
Yeah.
Well, why is not
Slight
Yeah,
issues. We have two slight issues. One is the part of the machine that we should use for this has failed. We can't get it repaired. And secondly, we can't get hold of the polymer, so we've got very little polymer available. So we've got to be very conservative with how we use the polymer.
How come you, out of interest, how come you can't get hold of it?
The supplier has changed it, and we found out what the equivalent one is, but there are all kinds of purchasing issues that have made it staggeringly difficult to get hold of.
And when the material
Ridiculously
changes, we have to run trials beforehand, and you see today's material is made from master batch and virgin material, so the master batch needs to be remade.
Right. That's a pain.
Yeah,
It's a massive
when
pain.
did they change that?
A while ago, I think, but it's not necessarily obvious. The company that sells it has changed as well,
Right.
which there's actually only one manufacturer in the world of this.
Yeah, they discontinued that rate. I think they may actually putting in some other things in. I mean,
Yeah.
to improve other properties. Depends on who are their biggest
Buyers, yeah.
customer.
Good. That's the two weights, is it?
Yeah.
Now, how are you going to label these fibres? How are you going to know which one's which?
Just writes me out. Piece of paper.
Paper we have plenty of. Now we need some of the team to start working on testing these straight away. Yeah. Otherwise,
Yeah.
you're going to run out of time. I've got 5 tests to do.
So
They're all quick, but
two of your fibers.
Okay. Yes.